Thank you for being so patient. I'm Josh Grindley. I'm a faculty member here for many years, graduate student before that. So I knew Cecilia Payne-Gaposchkin. That's my friend. Owen, of course, knew her much better, and others. But I've been here for a while, and I'm very honored to be able to introduce our speaker. And I will do so, and I will also show you a few very quick slides to introduce the night of the glass universe, which I am intimately involved with. I lead the project to digitize these plates. We're about a third of the way through. We have many people here, Bob Simcoe in particular, who designed our scanner. But it's all working well. We had a flood. When you read the last chapter of Dava's wonderful book, you'll hear about this. Some of you know about this. Many of you know about this. We've recovered from it. That's all the good news. Let me first introduce our speaker. I don't think I need for this audience to make much of an introduction because she's so well known to all of us. She has been a wonderful historian of science. Her books on Galileo's daughter and longitude, I think all of us have read. If you haven't, my God, go out and read it. Read them. They're beautiful books. And this book that we're celebrating tonight, which we're going to hear all about, and I'm not going to steal any thunder from our esteemed speaker, is, I think, at least for the moment, the capstone. Because those previous books, as I hope Dava may or may not tell us, relate to the story you're going to hear tonight, to what happened here in this very special time of the late 1880s, 1890s, 1910s, 20s, 30s even, of the women computers here, which we're going to hear all about. So I'm not going to talk about that. But let me tell you a few introductory remarks about Dava. She's won many awards, and I had a note sheet which has been misplaced. So now it's going to be from memory, and there will be errors, but excuse me. So Dava has received her degree from, I believe, Antioch. And yikes, I'm already wrong on the first one. So let me move on from her degrees because that isn't what you are here to hear about. But she's been awarded various honorary degrees, which probably most of us haven't heard about unless you've looked at her website. She's got honorary degrees from Bennington, from the University of Bath, an honorary doctorate from both of these, Doctors of Letters from Bennington, and one other. I won't try to, tell you something that is not 100% accurate, so let me move on. But Dava is a very special person and has been suitably recognized. And we want to do that tonight. So I'm going to show you, as I mentioned, just a couple of slides to introduce the plates and Dava's talk. So do we have our display? I hope we do. And there we go. Okay, so if you can read the text here, I don't have to read it for you, but just a few astronomical terms. If you haven't heard of the Small Magellanic Cloud, that's one of two dwarf galaxies. We used to think they were orbiting the Milky Way. We now know they're encountering the Milky Way and have been for some time. They will eventually merge with us. So they're not just going to merrily orbit forever. But the Small Magellanic Cloud is what I'm going to get to in just a second, is where one of the heroines, I should say, Henrietta Leavitt, made her fundamental discovery, which she reported in the 2008, my God. Terrible typo. 1908, off by 100 years. Annals of the Harvard Observatory, volume 60. That's incredible. All right. Well, you're all getting a good laugh out of this. That's good. She made this fundamental discovery that variables that she had observed and measured in the cloud had periodic variability, which was known for other variables. Eclipsing binaries by definition do that. But these are a different kind of variable, and I'm not going to tell you what they are because I suspect you'll hear more about them from Dava. But her discovery, which you will also hear about, was truly fundamental. And I want you to know, and it's in Dava's book, that in 2008, that's where the 2008 came from, in this room, we had an anniversary, centennial celebration of this fundamental discovery. And I'm going to claim credit, because I was the one who suggested that we heretofore name her period luminosity relation as the Leavitt law, and that is now what we call this. So what I thought you would like to see, since you're going to hear about plates, and this is the glass universe, was what one of these plates looks like. And Lindsay Smith, who's here in the audience somewhere, who's our acting curator of the plate collection and doing a wonderful job, found by looking back at Henrietta's 1908 paper in the Annals, that where she dutifully lists the dates of the plates that she made use of in making this truly her, epic discovery. One of them was taken on October 28th, 1897, 4.5-hour exposure with an 8-inch telescope. Wonders what you can do with a long photographic exposure. And what you can do is in the plate you're going to see next. Here's the plate jacket, and I thought Dava would like to see this. And some of you will recognize these things. These are the paper envelopes that these plates are stored in. There it is, plate number B20678. This is 1908, roughly 20 years after the plates were taken. And this is plate number 20,678 of one of the many telescopes. So Pickering was going wild, right? And his staff was, it was incredible what they were doing. And in the age of non-big science, I think this is worth another book on how Pickering ever really got this all together. It's, of course, in large part dealt with in Dava's book, but there's more to be told. So on October 28th, 1897, a 270, that's minute, 4.5-hour exposure of the Small Magellanic Cloud was made with a 8-inch telescope. It's that big, right? We're now talking about, our Magellan telescopes in Chile are 6.5 meters. And there's a Small Magellanic Cloud, and the plate has got somebody's notation up in the upper left corner as meteor, because as you'll see in a second, there's also a meteor trail on this plate, which somebody noticed. And Dava will recognize this, that this plate was notated by Solon Bailey, Professor Bailey, on January 14th as containing the meteor track. Little did they know when this plate was exposed in 1897 that it was one of a bunch that contained the data that Henrietta would use to make this wonderful discovery. So here's the plate. There's the Small Magellanic Cloud, and what you're seeing here are these wonderful annotations which we believe are in at least some of them, and we can't tell you which, but some of these are surely in Henrietta's hand. So these are marking Cepheid variables, these periodic variables with their luminosity versus period relation. And the meteor trail is what somebody later on or at some point outlined in red to make sure you didn't miss it. That was the key thing that somebody thought was interesting, maybe Bailey. And if you look carefully, you can see the track here. And if I just quickly take one moment to zoom in a bit, and I'm sorry, this is not much of a zoom. This does not do justice to the plate, because when you look at this on the original plate, it is absolutely staggering what you're seeing. There are 100,000 stars on this plate. It's absolutely fantastic. This is a photographic image of the plate where we have obviously not removed the annotations, which we're doing on most of the plates so that we can digitize them and get useful modern day scientific data. So because this plate is so special, we, the observatory, would like to present Dava with a copy of this plate. There it is, right there. That's what this stand is all about. We found a wonderful source in California who could print on glass with ceramic inks. This is not an easy thing to do. In the old days, what Pickering did, and of course Shapley that followed him, were to just make a positive print of the plate, or you could make it a negative print on another equivalent plate. Photographic plates are not made anymore. If they are, I don't know where the source is. Kodak went out of business long ago, as we know. So we had to do this with high-resolution Nikon images that we made of the plate. And I have a copy in that box to present to Dava, and I'd like to do that right now. I can put it down for you if you like. Okay. So it's carefully packed, and it's right there. And when you're getting your book or getting your book signed or whichever, take a look at this up close. It's really quite beautiful. So that's enough from me, and it's now time to hear from Dava. So.
That's mine.
Plug in there. Let's see. There we go. Hopefully this will.
We'll hope it works this time. No.
Okay.
Everybody, close your eyes.
Okay.
Okay.
There's a pointer if you want it.
Okay. Thank you.
Great.
Well. Thank you all for coming. This is just such an exciting, wonderful night. I had no idea half these things were happening. It's a little like an episode of This Is Your Life. Hi, Marcia. I'm very happy that all the people who really work here are here. The librarians, the archivists, the people who volunteer on the digitization project. It's just great to see you all and to celebrate this moment with you. And there are quite a few women astronomers in this picture. They're not the ones in the book, really, but they relate to the ones in the book because the ones in the book were really in at the beginning of modern astrophysics. And I think they have a great story to tell. And I'll point out, you probably recognize this person who's sitting in the front row. Thank you, Alyssa Goodman, for being responsible for the fact that we're having this event here at the observatory. Because I asked her to read the manuscript as a technical expert. And she got in touch with me right away that she wasn't really interested in reading it as a technical expert because she was so astounded that the women had actually been doing real science. All these years she'd heard their names and she thought it was just something cute or quaint. And in fact, they were really doing science. And she said, I want you to come and teach us about our history. So I'm going to make a push to have your book event in the observatory. And here we are. So that was really great. Thank you. Thank you for doing that. And we have all sorts of audiences here tonight. People who are extremely well informed about the subject, who actually know more about it than I do. So it was tough to think of what to say that would really be of interest to everybody. We'll see how I do. And among the many audiences, I would like to single out my daughter, Zoe, who's here because she is really the audience for the book. And I say that because when I write, I always try to have just one person in mind, which protects me from trying to write for the general audience, whoever that is. Owen Gingerich is here. He was my audience for Galileo's Daughter. Thank you again for playing that role. But I thought Zoe would be the perfect audience for this book because she's really a reader and she's very interested in women's history and in this period of time around the turn of the century. Not so much interested in astronomy, as she would be the first one to admit. But I thought if I could make this story interesting to her, that would really be something worth doing. And she tells me it came out okay. So I'm happy about that. And also, you know, as you've seen, she's a smart young woman in her 30s. And here we are in this historic place, but it's important to remember that all these people were very young when they were doing what they were doing. Pickering was only 29 when he was made director of the observatory. He had been teaching at MIT for about 10 years, and he was a physicist. And there was a lot of question as to whether, as a physicist, he should direct the observatory. But that turned out to be a really good thing. The other picture is his laboratory at MIT. He created a teaching laboratory where physics students could do experiments so that they could see things for themselves. That was his trademark as a teacher. And he was often approached by young women who wanted to be in the class, and he let them in. And one of them set up a physics laboratory at Wellesley College on his model. And even the observatory was young. It was a wooden building, none of which remains, but this is what it looked like when he took it over. And it had had 3 other directors before him. And he didn't know it, but he was about to become in charge for a longer period of time than all of them put together. And he worked with this telescope, which is still here. We want to see this telescope back in working order, back being used for open nights here at the observatory. There he is, sitting in the chair designed by it's not really him, I don't know who it is, but it could be. And the observatory was really focused on determining the positions of the stars. That's what the computers were doing. There were male and female computers. The early women here were the family members of the directors and other observers. William Rogers was a big name in determining star positions, and he had his wife working with him. But Pickering, as a physicist, was really interested in looking at the physics of the stars. And he started a program of photometry, of really trying to determine the brightness of all the stars. And he had to develop his own equipment to do that, because there was no equipment that was really good enough, in his opinion. So he invented a whole series of instruments that attached to this telescope, and then he went on to some photometers that had telescopes built into them. He was also really good at raising money, which, as anybody who runs an operation knows, is a crucial part of the job. And he was friendly with this couple. This is Dr. Henry Draper and his wife, Anna Palmer Draper. So Henry was really a medical doctor, but like his father, he was extremely interested in astronomy. And at that time, it was the amateur astronomers who got to do all the interesting things. If you worked at an observatory, you were constrained to do the scout work, the star positions. But if you had the independent wealth of your wife and the genius of your own resources, then you could look at the really exciting new stuff. And what he was interested in was spectroscopy, looking at the stellar spectra, photographing them, and figuring out a taxonomy of the stars based on their spectra. So remember, in the early 1880s, nobody knew what the stars were made of, nobody knew what made them shine, and nobody knew how far away they were. So there was a lot to do. And Draper was teaching at NYU, but he got all his affairs in order to give up his teaching and focus full time on taking pictures of the stars and analyzing the spectra. And just when he had that arranged, he fell ill and died. He was 45 years old. And his wife was devastated by the loss. She had become his assistant for 15 years. They had worked together on astrophotography. And she was determined to see his dream become a real project. And she knew Pickering. Astronomy was an intimate community. It still is. Most astronomers know each other because it's such an interrelated field. It so naturally involves people in several countries. So he wanted to help her. He thought the project had tremendous merit, and he really wanted to help her, and he tried to find people she could hire to work with her and get the job done. And it wasn't working out. She could see it wasn't working out. And so he hinted, and then she agreed to just give him the money and let him do the work. And she gave him the equivalent of his entire annual operating budget every year just to do this project. And Pickering was already seriously interested in photography. His younger brother was also teaching at MIT and was a photography pioneer, and they really thought they could do this. So this is the textbook image of a spectrum, what you show to students learning the topic. So there's the rainbow colors and the dark Fraunhofer lines along the spectrum. But when they were working, they didn't have color photography yet. Their spectra looked more like this, or the enlarged, detailed ones looked like this. The women often worked from pictures that looked like this. So each spectrum is a little tiny smudge. The dark spot there is a penny just put down on the plate to give you a sense of size. And so they might write numbers all over the plate to identify the various spectra and then read aloud, okay, number XYZ is type ABC. And they were looking at these patterns and coming up with categories based on the patterns and the lines. And Pickering turned that work over to his women computers. So it was an enormous project, difficult, but he trusted them to do it. And thanks to Mrs. Draper's money, he could hire a bunch of people to spend their time looking at these glass plates. And they worked in pairs. One would look at a plate and reel off numbers or designations to a partner who made notes in a logbook. And this is Williamina Fleming. She's one of the more famous ones, and she's also the head of a huge myth. She actually came to work here as a maid. She was Scottish. She had been a teacher in Scotland, but then came to America with her husband, who disappeared on her when she was pregnant. So she really needed a job. And she came to work at the observatory, but the Pickerings, because the residence was attached to the observatory. So the Pickerings realized she was really much too smart to be a maid, and they brought her over to the observatory and put her to work. And the story you usually hear is that Pickering was dressing down one of his assistants and claimed, "This is really sloppy work. My maid could do a better job." And then he installed her in this position. Well, if you read Pickering's correspondence and read what other people said about Pickering during his lifetime, he was the most polite person who ever lived. The idea that he would embarrass an assistant in public is completely unbelievable. So next time somebody tells you that my maid could do a better job story, just smile to yourself and move on. But she really did a great job, and she was the first woman to hold a university appointment at Harvard. She became the curator of astronomical photographs. Part of the reason there were so many women here was that the observatory didn't really answer much to the university. They didn't get any money from the university, and Pickering had a pretty free rein. The group shot shows Maria Mitchell, who taught at Vassar College, was hired early on by Matthew Vassar himself, and she educated quite a number of women who went on to astronomy, including, on the right there, Antonia Maury, who was a niece of Henry Draper. Antonia Maury had 8 semesters of astronomy with Maria Mitchell at Vassar College, and came to work here at the observatory, and also did analysis of stellar spectra and classification of the stars. And she made an important discovery of one of the first spectroscopic binary, so a pair of stars that nobody could resolve through even the most powerful telescope of the time by separating them into 2. It had to be looking at the spectra to realize that there were actually 2 objects there. But the person who really made the classification famous, successful, enduring was Annie Jump Cannon, who was a student at Wellesley College and studied under Sarah Frances Whiting, who was the person who had been trained by Pickering and who repeated his physics laboratory at Wellesley. And the lovely drawing of her on the right is from a children's book called Annie Jump Cannon, Astronomer, by Carol Gerber. And the illustrations were done by Christine Walton. And Annie Cannon was the first woman who came here not just analyzing plates, but also making observations through the telescope. So she was looking at variable stars, and she was classifying stars. Here's a little more of her kind of work. This is really not for everybody. Think of the concentration that's involved, the level of detail. One of the great pleasures of this project was getting to work in the university archives. And one day I requested Miss Cannon's diaries, which had to be brought in from the depository. Miss Cannon was a lifelong diarist. So when I opened the boxes, I really fell backwards a little bit because there was something so girlish about the way some of them looked. In the lower group here, the one with the binding around it, that is her journal from her trip to Europe after she graduated college. She took the grand tour with a friend of hers and saved every train ticket, the recipe from the ship, the recipe cards from the ship's dinners at night. And she was really a lifelong diarist. So on the right there, I don't know if I can read it from here, but she says, Cone took 6 chairs for mending, and in the top entry she had tea at her neighbor Ruth Munn's house, and a few other people were there. Margaret M. is Margaret Mayall. Some of you may know that name. And then so this was a 5-year diary. Oops. And so the lower one is a 1941 entry, and she says she went to Boston early and mailed her income taxes. And in 1941, it was March 15th that was the due date. So this was probably sometime in February or March. I've cut off the top of the picture, so I can't tell you exactly. But then she says she was classifying from 1:30, and Cecilia brought me home at 4:30. That would be Cecilia Payne Gaposchkin. And there is no entry for 1942 because she died very shortly after that last entry was made. So when I say lifelong diarist, that's the evidence. And I sometimes read books about history of science by people who complain about slaving in dusty archives. And I want to say, come on, nobody makes you do that. You do it because it's fun. It's really fun. And again, I am so grateful to all the librarians from the Walbach and the archivists from the Pusey Library who are all here because they just really were helpful and made me feel so welcome. Thank you again. Part of Pickering's project involved being able to photograph the stars of the southern hemisphere as well. And so he sent one of his best colleagues, Solon Bailey, to reconnoiter places to build a big telescope to take pictures of the southern stars. And Bailey went looking at places in California and South America. And later he went to South Africa. And he was the observatory's ambassador without portfolio. That's what President Charles Eliot called him. And this was the first place he picked in Peru, which he named Mount Harvard. He wanted to call it Mount Pickering, but Pickering told him he didn't deserve the credit yet. And so he called it Mount Harvard. It was a pretty slapdash affair, but he got a lot done there. And later he moved to a site near the town of Arequipa, which was in the shadow of a dormant volcano, El Misti. And there were several telescopes. Edward Pickering's younger brother, William, went down briefly as a director and built this elaborate hacienda, which cost a fortune, completely exceeded the budget, so that William had to be called back to Cambridge and fired. And Bailey went back, and this building was the home of the Bruce telescope, which is this instrument. And it was named for Catherine Wolfe Bruce, another heiress charmed by Pickering. He told her he wanted to build a giant telescope with a lens 24 inches in diameter, and he needed $50,000, and she wrote him a check. And she went on to offer lots of other money to astronomers everywhere if Pickering would help her pick the deserving people, which he did. And she was very happy with the work done by this telescope. Just a couple of weeks ago, Sarah Schechner and Ken Lowney took me out to Oak Ridge, where the decommissioned Bruce telescope now resides in its enormous packing crate. And I got to see those gorgeous lenses. There's a lot of history here. So while they were in Peru, sometimes they had a picnic. Bailey knew he was going for several years, so he took his wife, who was the one at the far right, and his son, who was about 3 years old at the start of their time in Peru, and she helped him count the stars. He got very interested in globular clusters of stars, which he photographed. So that's a globular cluster on the right, and this is a close-up. And they devised a very clever way of putting a grid over the pictures and then counting the number of stars in each grid. But it was, you can see as you get towards the center, it becomes mission impossible. But they persevered and counted into the thousands. And then they were also assessing the brightness of those individual stars. The plates themselves are just so beautiful, and those of you who've seen them, they really are thrilling objects to look at. And when I was trying to convince publishers that this story was actually something worth telling, I remember George Gibson, who's here tonight, looked at the proposal, and people were really worried. Could I find out enough about the women to make them distinguishable one from another? Because in the proposal, they kind of all sounded alike, you know, like a bunch of lady nerds. And the one character that really came through was the plate collection itself, because it is a character in the story. It's a major character in the story, and that's why it's the glass universe. And those of you who have not seen the plates, I really hope you get a chance to go and have a look at some of them firsthand. So here's another heroine who was mentioned at the beginning, Henrietta Swan Leavitt. Now you know a little bit about what she did. So she came, she had spent some time at Oberlin College, but then she went to Radcliffe, and she took the practical astronomy course that brought her over here for experience and work with the plates. And she wound up being hired not to classify stars, but to really be studying the plates and looking for variable stars. And when she looked at the Small Magellanic Cloud, she realized that, okay, here was a case where all the stars were pretty much the same distance away. So if she was looking at stars that were brighter, then they really were brighter than the others, because the distance question had been eliminated. And she made that pivotal observation that the brighter stars had the longer periods. And that became the basis immediately for calibrating the variables and figuring out how far away this object, the Small Magellanic Cloud, actually was. And then from there to figuring out the distances to all these globular clusters. And Harlow Shapley, who was at Mount Wilson at the time, looked at all those globular clusters and realized that the way they were positioned, they were actually encircling the Milky Way, and that the sun and the solar system were nowhere near the center of the Milky Way, which was a major discovery. And he said he really liked that discovery because it showed that man was not such a big chicken. And some people were very upset that man was not such a big chicken. But Shapley was not really interested in chickens. As some of you may know, he was extremely interested in ants, and was a serious researcher and wrote several scientific papers about ants. And I wish he could have seen this cartoon. This is a Charlie Hankin cartoon from the New Yorker. I don't have the caption showing. I'm going to tell, but it's almost, they do that contest now where you have to provide a caption. So the caption is, kind of makes you feel small, doesn't it? So here he is. He was also very young when he came here after Pickering's death as the 5th director of the Harvard College Observatory, and there was some question about his fitness for the job. He had a lot of big ideas and could be brash at times, and he was under observation for his first year. They didn't really give him the director title right away, but it turned out he turned out okay. And he inherited Pickering's wonderful desk. This desk was designed by Pickering. It does several wonderful things. It puts about 25 feet of counter space in a rather compact circle. And then it has a separately revolving bookcase at the center. And this was here for years. There are pictures of Shapley sitting at the desk. But then the desk got warehoused. Things take up a lot of room, progress. But I'll mention Sarah and Ken again because they rescued the desk and had the ability to install it, because this is not something you just bring home and put in a room. It has to be, because everything revolves and you can move your projects around like a lazy Susan, it has to be mounted in the ceiling and the floor. So it is in their home, and you see they have the bookcase full of relevant items, including a portrait of Pickering himself. And they tell me that when they finish reading The Glass Universe, they'll put it in the bookcase. And that'll be almost as good as getting a plate of Henrietta Leavitt's. Yeah. So Shapley's big contribution here, he wanted to start a graduate astronomy program. He felt if there had been a graduate program at Harvard, they wouldn't have had to import him from California. They would have been able to promote from within the ranks. And so the presence of women here had attracted one of Maria Mitchell's descendants to, not really descendants because she didn't have her own children, but a family member, to endow a fellowship for a young woman to come and work here for a year at the observatory. And the large picture is Margaret Harwood. And she was the first person to have one of those Maria Mitchell fellowships. And she did so well that the Nantucket group that ran the Maria Mitchell Observatory wanted her to come back year after year. And then they gave her, in her 4th year, they gave her a sabbatical year to go get her master's degree in astronomy at the University of California at Berkeley. And while she was away, she was offered a teaching job at Wellesley College at a nice salary. And the people at the Nantucket Maria Mitchell Observatory decided to offer her, to make her the permanent fellow and offer her the directorship of the observatory. And she accepted that. And then they thought they would endow another fellowship so people could keep on coming and working at Harvard. And that fellowship was called the Pickering Astronomical Fellowship for Women. So when Shapley wanted to have money for graduate students, the only money he had was this fellowship for women. So all the early graduate students were women. At the top is the first one. That's Adelaide Ames. She came in 1923. And then underneath is the second one, who was at the time Cecilia Payne, later Cecilia Payne Gaposchkin. And just like to say her daughter, Catherine Harriman-Danis, is here this evening, which I'm also thrilled to see you. Thank you. Cecilia had been a student at Cambridge University, and she had read about Shapley's work. She met him when he spoke in London and told him that she wanted to come study here. She knew her chances in England of having a professional career in astronomy were nil, and he brought her over on one of these Pickering fellowships. And then in the course of doing her doctoral research, she figured out the construction of the universe. She noticed that the most abundant elements in the stars were hydrogen and helium, which seemed completely impossible at the time. And she was advised to temper her comments in her dissertation and just say that it was probably a spurious result, but that was her result. And then it took only 4 years for the top authorities to say, yes, in fact, hydrogen and helium really are the predominant components of the stars. So that was a great success story, and she spent her entire professional life here. So in the plate stacks, there are still all sorts of wonderful things people probably don't even know are there yet. Things turn up all the time. Lots to be looking at. This is how the plates look in their jackets. Some of the jackets have been on there for decades, maybe a century. Here's Josh at work, looking at the some of the equipment for the digitization process. And you think about how enduring Pickering's vision is, that this material still has so much value that the plates have to be digitized, partly to preserve them, because who knows how long that emulsion will survive, but also just to make the material available to people all over the world. Pickering used to actually send plates to people, or have people come here and just work here for weeks or months so they could have access to the plate collection. So you often hear that these women were forgotten or they never got any credit. I would like to say that that's not true, that they really did get a lot of credit, a lot of recognition. Pickering always mentioned their names whenever he published anything about what they had done. And Miss Cannon was so famous. Here she would, the Wonder Woman comic book used to put out, would bow to a particular Wonder Woman every now and then. And here she is, as a modern queen of astronomy. Just to show you some of the recognition they did get and continue to get. So this is a website called Rejected Princesses. Women who are too awesome, awful, or offbeat to be in a kid's movie. And so Annie figures in that. And that's Pickering holding the ladder for her. And see the rest of the group at the back. This is actually Henrietta Swan Leavitt. No, it's actually one of the American Girl dolls, but it was made as a birthday present for a young woman astronomer by her parents. So the clothing was sewn. The skirt was this young woman's prom dress. And then her father made the accessories. So the accessories include the light box, a magnifying glass, a fly spanker, and then a book of sample plates and her 1908 paper. And then The Cosmos television series by Carl Sagan had just a tremendous reach. Carl Sagan had a tremendous impact on my life. I went to a public lecture that he gave in, must have been 1972, before he was really famous. I was living in Ithaca, and he was right there. And listening to him that night really changed the course of my life. And when his Cosmos television series aired, it created an entire generation of astronomers. I interviewed so many people who traced their interest in the subject to that series. So recently, Sagan's widow, Ann Druyan, and Steve Soter at the Hayden Planetarium in New York redid the series with Neil deGrasse Tyson as the host. And this time, it included an episode about the Harvard computers. It was called Sisters of the Sun. And so that's Annie Cannon there. And we also have Henrietta Leavitt and the rest of the gang. And this has had such an effect. There are 2 new plays being written about the women. There was a play that showed briefly in New York for about a month, and every night there was a woman astronomer there to do the talkback with the audience so that people's questions could be answered. And it was so successful that they are now doing a web series, a 9-part web series about the women. Have any of you seen this? You can get this on a T-shirt, and some of the people in this room actually have that T-shirt. So, Henrietta Leavitt, Anna Jump Cannon, and Cecilia Payne. They were actually designed to be Lego figures, but I don't think they made it all the way to plastic. They're just on the T-shirt. Here's another person who has been inspired, motivated by the work of the women. This is artist Leah Halloran, who has spent a lot of time here looking at the plates, working in the archives, and making an art installation that will open next spring called Your Body is a Space That Sees. And these images are about 6 feet square. So that'll be great to see that come to life. Yeah. This is the morning after. All those years, the reason we are all sitting in this brick building is that Pickering was so worried about fire. The observatory building was a wooden building, and it gave him nightmares. When these plates began accumulating, all he could think about was what would happen if there were a fire and we lost them. And he agitated and fundraised and got a brick building built. And later, the building got expanded, and in the final expansion, the room we're all sitting in tonight was added. But the thing that undid them was not fire, but water. But I'm happy to report, as Josh has already told you, that it was not the end by any means. Volunteers came, carried the plates out. They've been dried there, and the digitization, all the equipment was submerged, so that all had to be rebuilt. And but everything is going again. So I salute you. Carry on. And then just recently, whole boxes of things were found in the repository that were from the plate stacks. And who knows what's in there? So this has started a whole new project called PHEDRA for preserving Harvard's early data and research in astronomy. And tonight I volunteered because I really don't feel I'm finished with the ladies. So this will be a great way to to continue my association with them. Whoops. I'm going to close this. Can we just turn that off? Great, thank you. Can we really turn it off and not be distracted by it? Because great, it's gone. Okay, because this is a history story, and sometimes people ask me, well, what message do you want your book to send? And I don't really want it to send a message. I wanted to tell a story. I think it was a great story even before I came to the telling of it. But I think now, in the light of recent events, it's maybe even a more important story than I thought. Because there is a big anti-science sentiment in this country that I find very frightening. And I think the more we can tell stories about science and show that women have been in there all along, we shouldn't be joking about repealing the 19th Amendment. It's important to recognize the work of scientists and support the ongoing work that you do. Thank you.
Wow, wonderful.
Thank you.
We have time for some questions, comments? There must be lots of things people would like to
There's
ask.
somebody.
Peter.
The point you made about the fellowship that came up for the women, how much overlap was there between the ones who got the PhDs afterward, of which there was a large number? I think Harvard was graduating more women out of PhD programs in astronomy in the 1920s than it was men. How much overlap was there with the women who made the important discoveries earlier?
By the time the fellowships came along, the only one of the famous ones who benefited was Cecilia Banks. Yeah, Miss Leavitt had died, Hannon was older, Miss Fleming was gone. An interesting just coincidence that happened to me, I was working at Smith College the last 3 years, which was great because it put me close enough to the observatory to come here once a week easily. And Smith was one of the feeder schools to this project. And Priscilla Fairfield Bach had been at Smith College. And in the archives, I was reading all of her correspondence with Shapley because she had duties at the Smith Observatory on the weekends. But when it rained, she could get away, and she would come here and work. And so she usually wrote to him on the Smith Observatory stationery. But one of the letters she wrote from home, and she put her address in Northampton, Massachusetts, and it was the building I was living in. So that's when you know you're in the right place, doing the right thing.
Wonderful.
No tough questions. I felt like I was preparing for the oral defense. Okay, we could just party. Did you have a question? Somebody there.
How did you come to write about this topic? How did you first learn about it?
How did I first learn about it? I interviewed Wendy Friedman more than 20 years ago when she was the head of a Hubble Telescope Key project. And she mentioned the name Henrietta Leavitt to me. And that was interesting because I'd never heard of her. And Wendy was one of the people at your meeting who was now a strong defender of the idea of the Leavitt law. And then I realized that there was a whole room full of women here, which was really interesting because you don't think of Harvard as a place where there were a lot of opportunities for women in the 1880s. So, so that's what got me interested. And then the Astronomical Society of the Pacific did a whole issue about women in astronomy in one of their, I still have it, in one of the issues of Mercury in the early 1990s. So I saved that. And it was just a question of, you know, was it really a doable project? Because there were so many women. And could you tell a story about all of them? And I was still debating that when I started, was actually looking to see if any one of them would carry the story and the others could just be minor players. But again, between having the plates and then just having the way the science developed, it had to be about all of them. And there were names I didn't include. You know, if there's a volume 2, I'll get to the others someday.
In fact, there are lots of names. In the back of your book, you have a long list, most of whom I must confess I've never heard of.
Okay.
What were they doing? Were they just, were they, you know, minor wheels in a cog machine, or?
Yeah, I mean, it took a village to do that work.
Exactly.
Yeah. Yeah.
So I'm curious, the women later in sort of when they were graduate students, obviously they were writing papers and they were writing theses and things like that. But the earlier women, the very early women, I still am under the impression, hopefully I'm wrong, but that other people always wrote up their work. Did they write up their own work?
It depends how you count. So Mrs. Fleming did the first catalog of spectra for 10,000 stars. And Pickering wrote the preface, in which he said that all of this work was done by Mrs. M. Fleming. And, but when Antonia Mori published her catalog, her name was on the title page. So, and with Henrietta Leavitt, the first announcement of her work was in a circular. And Pickering just wrote all of those. You know, it wouldn't have mattered if it had been Bailey or one of the others. He would have written it and just mentioned the person's name.
I found that surprising that Pickering wrote the circulars. Why were they?
He did everything.
Yeah.
He did everything. I would also like to tell Alyssa's story, because one of the things, so Alyssa Goodman sitting in the front row here, who is a professor here, and professor of astronomy. And as a young astronomer, she was offered the Annie Jump Cannon Prize, which is a prize that Miss Cannon herself endowed. But people, you know, those historical facts just escape attention. People don't, she didn't know the history of the prize. And all that struck her was that this was a prize just for women. And so it was kind of a second-rate prize, and she refused it. I think a lot of people might feel that way, so it's possible that people will agitate to change the nature of the prize and have it awarded to a young astronomer instead of a young woman. But now it is awarded every year.
I certainly would have taken it if it was for just a young astronomer. And to be fair, I wasn't offered it, I was offered the nomination.
The nomination. But you would have.
Nancy, you have a question?
These women left very, very differing amounts of records behind them. I think, didn't Annie Cannon wrote a lot herself, and Margaret Mayall, but where Henrietta Leavitt, really, really sparse. Isn't that quite a challenge for an author trying to pull it all together and some balance and some...
Yes, it was a challenge. And the interesting thing for me is that the one person who had really had a biography written about her was Henrietta Leavitt. And she's the silent woman. Mm-hmm. There are no letters. Mm-hmm. There are her logbooks. But George Johnson, who wrote that book, You can see he's reduced to giving you her grades at Harvard. Whatever there was, he reported, but, and he could talk about her work and the significance of it. But there's nobody like Ms. Cannon for an on-site appraisal of what's really going on.
Although I think, weren't they all sort of beset? Henrietta Leavitt at one point went home to take care of family members,
Yes.
as did Annie Cannon. I mean, they kind of went, they did these amazing things, but it was being single themselves. It was against a background of a huge amount of back and forth and contribution to their families and.
Yes, yes, family obligations. And at the beginning, they didn't get married, because if you got married, you left.
Yes, Bill.
What were the forces that changed this kind of astronomy so that human computers, female computers, were no longer involved? Was it mechanization?
Yeah,
So
Yeah.
machinery and replaced?
yeah, yeah.
human
So
operation?
the computers were still here at the start of World War II, and they all went into war work. Some of them were teaching celestial navigation. Mrs. Shapley was doing ballistics for the Navy. And then some of them came back, but then it was possible to turn that kind of work over to machine.
Have you seen Lauren Gunderson's play, Silent Sky?
I have, yes.
I saw it when it was at the Mountain View Center for Performing Arts. I produce science theater and film as well.
Uh-huh.
It was profound. What did you think about her work as a playwright and also the play itself?
Well, no, I didn't see it, I've only read it.
Oh, you haven't? Okay.
No, I haven't
Because
seen it performed.
I would hope that anyone here to bring it to the East Coast as soon as possible.
There was a reading of it here at the observatory, wasn't there?
But the Mountain View Center for Performing Arts, they did the most stunning set, and you're talking about the interpretation of and I believe truly right now the time is to do narrative science and double down exponentially on that.
But didn't it turn into a love story, doesn't it?
So what happens is a lot of times it goes that direction.
Yeah.
I'm against that
Yeah.
personally. I think
Yeah.
that, I
I
think
think
we
that
don't.
was a stretch.
Yeah.
Yeah.
However, I would say that part of the weaving was very secondary, and what they did to create the science was magical. I mean, they really, and they did a great set. But I'm wondering, have you had conversations with her, or?
No, because
Okay.
she wrote that play before I came to the story. And there's another person working on a new play, which I believe is called The Women Who Mapped the Stars.
Who is that?
Joyce Van Dyke?
Yes.
There's actually another play called Insignificant.
Oh,
That was
Insignificant.
in New
Yes,
York.
that's the New
Is that
York
the
one.
one?
Right, that's the one that will be a web series. Yeah, Insignificant.
Why is it called that?
Why is it called that? I think it's a pun on a significant number. I got my title.
Your title is great, by the way.
Thank you.
Other questions? Well, if not, we've got, I hope, a long line of people who would like to have Dava sign the book. Thank you so much for